In this video, I'm going to be giving you an intro into unit testing. I'm going to be telling you what unit tests are, why you need them, and we're going to be doing a demo in Visual Studio with C# and MSTest, so that by the end of this video, you're going to have a firm foundation on how to start writing your own unit tests. Let's get started. So unit tests are small pieces of code designed to run really quickly to test small units of your codes, usually classes, functions, and methods, to ensure that they always produce the same intended output. The goal is to have these tests run every time you build your application, so that any changes you make to your code will get verified by your unit tests, so that you always ensure that your methods are producing the same output every time. This has huge benefits, of course, because it allows you to make changes to your code base confidently, knowing that if you've made a change that has affected the overall outcome, your unit test is going to fail and it's going to tell you, hey, you've done something wrong to break your code. This effectively speeds up your development process because you're not going through all that code and manually clicking items or manually testing your code over and over again. A great side effect of writing unit tests is the fact that it will get you to start writing code and start to change the way you think, so that you write code in smaller isolated batches that are more suitable for unit tests. This is great because this is a direction that we should all be writing code, ends up resulting in considerably cleaner code following the single responsibility principle. It's easy to argue that unit tests also speed up development considerably, at least from a maintainability point of view, because whenever you're writing changes, you already know when something has gone wrong immediately and you can fix it there and then. Unfortunately, as with all good things, there's a downside. Unit tests can be quite monotonous and tedious to write. There's a couple of things you can do to mitigate that, but we'll get into those a bit later on. Right, let's switch over to Visual Studio and write our first unit test. Right, so here we are in Visual Studio. I have some application. This is completely irrelevant, whether it's a console or a web API or whatever it is, it's largely irrelevant. Ideally, what you should be having your core business logic in a separate class library, and this is the thing that we're going to be writing unit tests for. I have a calculator class here that just does a couple of simple things. It adds, subtracts, divides, and multiplies. What we're going to be doing is, for our first unit test, we're going to be making sure the add function works as intended. So what we want to do is we need to create ourselves a unit test project. So we're going to go in here, new project. We're going to be searching for test framework, and you'll see you've got a couple of options here. We've got MSTest, we've got N units, we've got an X unit. So the difference between these are just different testing frameworks. So no one of these is better than the other. It's really just a different syntax. And personally, I tend to stick with MSTest because it's already built into Visual Studio. The others rely on pulling down some NuGet packages. It's really personal preference. One's not better than the other. X unit and N unit used to be very popular. My MSTest used to drag behind somewhat and lacked a lot of the features. That's not the case anymore. So we're going to be doing MSTest today. So create a new project. What you want to be doing here is how to name it. You really just want to name it based on whichever class library you're testing, and then add just a test suffix to that. So my class library that I'm testing is markinman.library. So we're going to be calling this one markinman.library.tests. So next. So here in our Solution Explorer, it's quite clear that markinman.library.test is the test project associated with this library we're testing. This is quite important because you could quite easily have tons of different class libraries doing different things, and you would want different unit tests to be grouped to test those particular libraries. Cool. Going to delete this useless default one that Visual Studio always creates. Right, so what we want this to also do is we want this test project to follow the same structure of the class library we're testing. So here we're going to go and create a new folder called math to simulate the same one. And what we're going to do is the first class we want to test is the calculator class here. So we're going to go and make a new class called calculator tests. It's just going to be that name of the class we're testing with the test suffix towards the end of it. And here we go. Right, so it's created a standard class. The first thing we need to do is tell Visual Studio that this is going to be a class that contains a bunch of unit tests, and it needs to process this in the MSTest framework. So by doing that, we will give it the test class attribute. So if it doesn't recognize this test class, you will need to write, you will need to do a .NET restore in the NuGet packages. So we're going to write our first unit test here to test the functionality of the add method in our calculator class. We're going to create a public void. We're going to create a public void method that is testing the add functionality. How we want to name our unit test really consists of the a three-part name. So we really want to do it for the method name we're testing, followed by the scenario we're testing, and this will all make scenario we're testing, and the expected outcome. So it's we're going to be following this in the way. So let me just make. So we're going to be following that sort of naming convention. So in this case, the method we want to test is add. The scenario we want to test in this case is we want to add two whole numbers. And what we're expecting the outcome to be is we want it to be the sum of those numbers. Right. And it's a method. Okay, so once again, similar to what we've done with the actual test class, we need to tell Visual Studio that this is a unit test. So we need to give this the attribute of test method. This will make sure that Visual Studio, or the testing framework, in this case MSTest, will actually treat this as a unit test, this piece of code. We'll actually notice that Visual Studio changes the icon over here, which gives us options for running the unit test. We'll see shortly how that all works. Okay, so how we structure the code inside a unit test is a common pattern is the AAA pattern. That is where we want to, where we follow the arrange, act, and assert. So under the arrange section, we prepare our code for the test. Under the act section, we will call our method, we'll perform the method we're testing, and then the assert is we're checking it for the expected outcome. So in our case of our add method, we are going to create a variable called calculator, which is going to be, and we're going to make our calculator, an instance of our calculator class, which is what we're going to test. Here it doesn't recognize it. The reason is because we haven't yet added a reference to the library. So what we could do is we could go here and then add project reference and then find it that way. Easier way is to go control dot, and then here is an option to add a reference to a markup.math library. Now it sees it. So we've got our calculator. We've got a calculator class. Then, so that is our range. In this case, we've done our setup. In our act is where we want to actually call our method, and we want to call the add method. And what we're going to do is we're going to give it two numbers to as parameters, and I'm just going to say 1 and 2. And what we're going to do is we're going to assign that to a result. So whatever comes out of there, and we know that if the add method works correctly, it's going to be a 3. So what we want to do is in our assert, we want to specify the thing that we expect to be true. So we're going to call assert, and we're going to say are equal, and we're going to say what we're, if you have a look here, what's expected, and then what the actual value is here. So the value that we expect the outcome to be is 3, and we want to check the actual value 3 against the result that came out of the calculator. So what we're effectively saying is here, our unit test is going to create a new instance of our calculator class. It's going to call the calculator, the add method, passing in a 1 and a 2, whatever result we get back from that, and we're saying it should be equal to 3. Do a comparison and tell us if that is what happened. Was it a 3 or was it something else? And that's really what we're going to do. So we're going to save this, we're going to build our application, and then we're going to run our first unit test. So up here from the Test Explorer, we can go test and then run all test. You'll see we got a separate tab all in itself. And here it will say mark image library.tests is the project, our class test.math, and then our calculator tests. And then here's the method that was actually run. Tells us how long it ran for, and the green tick obviously means that this particular test ran successfully and passed. And that's how long it took. So now we're at the point, and to show you this where the power comes in, if I want to go and actually introduce a bug into the code here, so let's just say somebody made a change and they made a typo, and instead of putting plus they put a minus here, for example. If I have to run this unit test again, you'll see our tests have now failed. And effectively, here's the reasoning down here. It's saying the assert, our test, the assert equal failed, and it said we expected the value of 3, but we actually got the value of -1. So now in this situation, we know that someone has made a change, a breaking change in the code, and then we can go and find, there was actually the plus. There we go. We can run this again. And now we know our code has been fixed. Right, so the add method on the calculator is pretty simple. Let's do some others. So here we've got an email validator class. It's a really simple class that just takes in a string and checks if it's null, checks that if it has an @ sign, and checks if it has a period as well. An email validator, a real world email validator would probably be a lot more complicated than this, but ensuring that this always occurs before this, for example, but whatever, this is for our example, is fine. So right, so we're going to do the next thing. Let's get rid of this calculator class. What we're going to do is we're going to ensure that our project has the same structure again. So I will create a folder and we're going to call it strings. And we're going to create a test class, and once again it's going to be the name of the class we're testing, followed by the tests. We're going to ensure that this is public, and we're going to slap on a test class tribute, and we're going to create a test method, and our test method, our first test method is, we go back to, if we just expand this, the method we want to test is our isValid, and it just takes a string. So what we're going to do is we're going to create once again, our naming convention is the method we're going to be testing, the scenario we want to test, and the expected outcome. So this email validator effectively has 3 or 4 different code paths. So we could have a scenario where the email address is null. We could have a scenario where it doesn't contain an @ we could have a scenario where it doesn't contain the period, or we could have a situation where it passes all of those. So here we need to write 4 unit tests to make sure we test every one of these code paths. So the first one we're going to be writing is we want to make sure that it validates a proper email address correctly. So let's say our first scenario is valid email address, and in this scenario we want it to always return true. So once again we're going to arrange, and then we're going to follow act code, and then finally we're going to make an assertion. So under our arrange, we're going to create a new instance of our validator class. So this is going to be our email validator, and then we're going to act on it, where we're going to get a result from our validator. We're going to call our valid method, and here we're going to pass it our test parameter. In this case, we want it to be a valid email address. So here we're going to pass in, I don't know, Luke Skywalker at deathstar.com, whatever. Okay, so that should meet the criteria. We know we have an @ sign, we know we have a period, and that's it. And then here we're going to make the assertion. So this assert is part of Microsoft's testing, the MSTest test framework, and we can assert for all sorts of things. So previously in our calculator test, we did an assertion checking that these two values were equal, our expected outcome and the actual outcome from the actual outcome from the method. In this scenario, we want to just, because it's a boolean that's being returned, we can do an assertion to say that we want to assert that the outcome is true. If you have a look at some of the options here, there's all sorts of assertions. You can check if things are equal, they're not equal. You can check if the instance is the returned is a particular type or it's not of a particular type, whether it's null. You can check for exceptions. You can check if something raises an event. So there's all sorts of things that you can validate or check that your class or your method is doing. Okay, but in this case, we're still keeping it simple. We are just checking that the outcome of this is valid, is true. So let's go and run this. So you can see on our test explorer over here, it's this blue icon indicating that we've never run this test yet. So let's go and run this. And it passes our first one just great. To ensure that our test is actually working before we go any further, let's just put something that we know is not a valid email address. So if we do something like that, I'm going to run this test again with Control-RT. Oops, Control-RT. This should run our test again, and then this time it actually fails, and it's saying that is true failed, and it's pretty much saying that yeah, it failed, which is good. So that means with a valid correct email address, our test passed. With an invalid one, it fails. Let's go on quickly and write some of the other tests for the other potential. So all we've done is we've effectively tested this final outcome over here. Let's quickly write the unit test for the other execution paths. So once again, it'll be the same. We're still testing the same method, so it's got the same name. And the next scenario we want to test is that if someone passes in an empty parameter, and in this case, it should return false. We want another one that is going to be valid, and where we email with no @ sign, and that will also return false. Copy this. Oops. And then we can, and then our last one is an email with no period that was passed in. Oops. Okay, alrighty, return false. Okay, with the next one, we're going to create our validator again. New email validator. Oops, new email validator, and here we're going to call validator.isValid, and then this time all we're going to be doing is we're going to be passing in our email address missing the our email address that's missing the @ sign. So here we can just take that out, and then once again we can call assert dot. In this case it should be false. We want to make sure that it is false in that situation. And then likewise with our checking that we have the period in place, we can add our @ sign back in, because we're only testing one thing at a time, and that is pretty key. We're not testing anything else, so each test needs to have a specific scenario and have a specific result that we are looking for. And then done these completely wrong. So this is the scenario with no @ sign, sorry, and this is the one where we have no period. So here we have an @ sign. There we go, no period. This one is an email with no @ sign, but the rest of it should be okay. This one is an empty email, so here we want to be passing string.empty. And that's it. We're going to go and run all our unit tests. So now that we've written our unit tests and we have our code passing successfully, we can make changes to our code safely and confidently, knowing that if we make any mess ups during the process, that our unit tests will catch our problem. So let's just say, for example, I thought that using contains was particularly not performant. It's not the case, but just as an example. And let's pretend that I wanted to say, let's use index of instead. So let's say index of 0 is greater than 0. So that largely should be the same sort of code. And what we're going to do is we're going to go Control RA to run all the tests. And here it's already told me that 2 of my tests have failed. And this is where the naming is so important. So here the call to isValid failed, and the email with no @ sign returned false, which it actually returned true. So clearly that's broken. And then our valid email also, when it should have returned true, it returned false. So effectively what it's saying is, when we pass this string to it, to that method, it said that this is no longer a valid email address. And the reason is because what we're saying here is this index of greater than 0 means it was actually found. So what we want to do is this needs to be equals, and we'll run it again, going Control RA to run all the unit tests. And now our valid email has passed, but the email with no sign has still failed. The correct implementation we should use here is the index of should be returns -1 when it doesn't find the thing we're searching for. So now let's go and run this again. We can run everything. And now all our tests pass. So it's important to know you should only be writing unit tests for your public facing or your public API section of your class, and by that mean just your public members. So let's say, for instance, you had a private method, and we can use this one as an example. Let's say if I extract this method to check, and I have a method called has @sign, for example. Yes, that's fine. Whoops. And we do the same thing over here, and we extract a method and we call it has period. So here we have 2 private methods, and now that we've made changes to the code, let's go Control RT again to run our test to make sure we haven't broken anything. No, we haven't. It's worth noting, just want to make highlight the icons here as well. These are the dark green icons to indicate these are the tests that were run. It hasn't actually reran the calculator test because nothing has changed in the code there. But they're still showing that they pre-test the test they passed the last time those tests were run. So here we've got some private methods. There is no need to write unit tests to test these, because these, as a side effect of testing the public method, we inherently test whether they work or not. And the only thing that's really important is the output of this method, because that is the public facing API that other classes are going to use. So how this thing works internally doesn't matter as long as it gives the output to the class that's using it correctly. One other thing that's worth knowing is there's a methodology called test-driven development. It's quite a thing, but it's definitely useful, and even if you don't practice it, it's really good to know about it. The idea is that you write the unit test before you write the code. This has a bunch of benefits, and in certain situations can be really powerful, but a really difficult way of thinking. And ideally, if I use the example of this palindrome checker, so here we have a class called a palindrome checker, and just if you don't know, a palindrome is any word that is spelt the same. It's a word that's spelt the same as forward and backwards. So here, for example, we don't actually have any code yet on how to test for if a string is a palindrome or not. So here we could let's quickly make a palindrome. Here we have a palindrome checker test. Right, so the thing that we want to check here is we want to make sure it's spelt the same backwards and forwards. And in that situation, this the Boolean method would return true. Okay, and then we want to get our result. And here we're going to go checker.isPalindrome. And in this situation, we actually want to put a valid word. So this can be anything. So for example, mark, and then I can just spell mark backwards so that this word is spelled the same as forward as backwards. We want to use test scenarios that are very easy for anyone reading our code to understand. So someone might come along with this code and say, mark cram, what even does that mean? So let's use another word. We can use mum or mom for our USA viewers. And here we can do our assert. Right, so the first thing we want to do is if we run this now, this will fail because we don't have any code yet to actually pass the test. So now that we know what the expected outcome is, we can now write our code to make sure that this passes. And in test-driven development, this is the process. You first want the test to fail. You write some code, get that test to pass at the easiest way you can get it to pass. Then you will refactor the code again and again and again, and whenever it fails, you make sure you refactor it till it passes. So the first thing we want to do is we want to get this code passing. So the easiest way to get this passing is to say if the text equals mom, for example, then we can return true. Otherwise, we can return false. Okay, and let's run the test. Great, so now it looks like our palindrome checker is absolutely foolproof because our unit test that checks that specific scenario works just fine. So now we're going to start writing some other tests here. So let's go and add a few more tests, and this is why you really need a couple of tests to check every execution path to make sure that your unit test is as robust as possible. So let's take a scenario where we have a single character and this should return true. So here we have tested single character. So, and let's put the letter M in, for example, or letter A, because it's even more, I don't know, basic. So here, because the letter A is spelt exactly the same backwards and forwards, this should pass. So if we run our unit test for our palindrome checks, and here it's obviously, here we have a situation where it is passed our return true, and it's failed, it's passed our spelt the same backwards and forwards, but it's failed our single character test, which is absolutely correct. So now we would now need to start writing some code to handle, to make sure it passed both of those tests. So here I could put in some real code, and let's go and do this. And here we've got a loop where, and as the code loops, it starts reading one side from the beginning, and it checks that each character, the first character, is it equal to the last character. Then it moves one character in, checks is the second last character equal to the second last character, the second character equal to the second last, and third, and so on and so forth. And let's run that. And now both of our tests are passed, and now we can start adding some more tests. For example, I can add one more here that goes and tests for a word that isn't a palindrome. We want to make sure that it doesn't. So Mark is definitely not a palindrome, and we want to make sure that this returns false. So once again, let's run our unit tests. And here we have a situation that it all passed. So this seems pretty good. We could add more tests to make sure that we should check. Let's say, for example, what happens if we pass it an empty string? That should also return false. So here we have a situation where we would pass it a string.empty, and let's run this one. And that fails because at the moment this is effectively not looping through here, and it's just hitting the true at the end. So once again, this now says this drives the code that we're writing. By writing the test first, it drives us to write stronger and more robust code. So here we would need to put a check, and we would say if null string.empty, Visual Studio already knows what we should. I like putting everything in curly braces to make it very clear how it's reading. And here you can actually see at the top here 3 out of the 4 tests is passing. And there it tells us which one's passing. There's another way that you can, if you find that easier, and there it runs all 4 of them and passes. So there's a little bit of there's a bit of an intro into test-driven development on top of your unit test. It's a really good tool to have in your toolbox. There are some scenarios where it's very, very strong and powerful. Some of the caveats with unit testing is that I definitely need to mention. It can feel like a lot of unit tests, it feels tedious, and you think, why am I bothering to write this? I know that my test that checks if something is null is going to work. Why do I need to bother writing the unit test? It just feels like a waste of time. So while I would agree with that, there's a lot of times when it feels completely unnecessary to write unit tests. I would reserve unit tests for the most critical parts of your application, or the parts that you know are going to be changing frequently. The benefits that you get out of that, where having confidence about that code that you've written that is particularly complicated or super critical to your application, unit tests are absolutely invaluable. Another scenario where you may end up having is that you are working on some code someone else has written, or some legacy code that is completely untestable. If someone hasn't written their code in small chunks of a function that just do a particular thing, if they have one big monolith application, that is very hard to unit test. Unit test functionality really has to be embraced by the members in your team so that everyone is on board with writing code in well-structured, small chunks of code that just do one thing. This definitely promotes a style of writing cleaner code. We can all benefit from writing more unit tests. Thank you very much for watching. If you made it to the end, I really appreciate it, and I hope it helped. I will see you in the next video.